Alright, welcome to CARBIDES. I'm going to briefly explain the mechanism on how we're actually going to prepare alkynes. And I have 5 methods with me here, and I'm going to explain how we can actually do them with ease. Now, let's go. Now, the first one we use we get alkynes from what? Metal carbides. And that's not all. It's called hydration of what? Metal carbides. Do you understand? So now see what we do. We first get a metal carbide. And which one do we use? We use calcium carbide. How do we get this guy? We mix coke and lime to give us what? Our calcium carbide. Now that's not all. We can't get our alkyne from there. We now what? Attack this calcium carbide with cold water. This reaction is very vigorous. After this reaction, we will get ethyne. Now note, this particular method is mainly and peculiar for ethyne. Okay? Now, looking downwards, alkylation. This one is kind of simple. It's from the name, you know, it has to do with what? Alkynes. Okay? Now, what do? We use the terminal alkynes. We all know what terminal alkynes is. Alkynes which have their triple bond at the last carbon, or we say the first carbon, anyone first or last, as far as at the edge. We now make it to have a what? Displaceable hydrogen, a acidic hydrogen. Do we understand? Now, moving forward, when we use the terminal alkyne to react with what? A very strong base. And we have a good example of that. Our sodium imide here. When it reacts with this guy, that's all. It will give us what? An acetylide ion. Now I know you might be confused. You don't know what acetylide ion means. Don't worry, I have the solution for that. I actually made a complete video where I explained every preparation of alkynes, and I gave structures, examples, and good definition on how we're actually going to prepare alkynes. So if after watching this video you feel your knowledge is not enough, please check out this video, the diagrams and how the real mechanism works on how this acetylide ion is formed and every other thing is formed here. You will know them in that video. Okay? So now, on that note, let's continue. After the acetylide is formed from the reaction of this strong base with this terminal alkyne, we now further react this acetylide ion with what? Our alkyl halide here to give us a higher alkyne. What do we mean by higher alkyne? We mean a longer chain alkyne. It actually adds this alkyne by 1 carbon. It extends the chain by 1 carbon. Do we understand? So now moving forward, dehydrohalogenation. Now it has to do with what? Vicinal dihalide. Now if you don't know what vicinal dihalide means, or you are like confusing yourself between vicinal dihalide, geminal dihalide, and central halide, don't worry, I have the solution. There's this video, I made the difference very clear, so check it out, about 1 minute video or so. Alright, so moving on, when we use this vicinal dihalide to react with a very strong base, what happens? It removes the halogens present in the vicinal dihalide, reducing it to what? An alkyne. Do we understand? Now moving forward, the other one, no, there's something you have to note. It's very important to note this. In this reaction, we need heat, please. It's a condition, a very important condition for this reaction to take place. So now, moving forward, we have what? Dehalogenation. From the name, we know we have to remove halogens. Okay? So now, moving forward, we see tetrahalide here. What is tetrahalide? It has to do with 3 halogen presence in a organic compound, and this organic compound is likely to be an alkane, single bond, possessing what? 4 halogens. Now, this zinc here is going to react, is going to attack our tetrahalide, removing the halogens present to reduce them to what? Alkynes. Do we understand? Okay. Also, this guy too, heat is going to be needed for this reaction to take place. Now, we look for the final guy, dehydrogenation. Dehydrogenation. Now this is very simple. It has to do with what? Removing what? Hydrogen molecule. I didn't say hydrogen atom. I didn't say water molecule. I said hydrogen molecule, which means 2 hydrogen will be removed. Now, in this case, when we use an alkene, when we remove 2 hydrogen from an alkene, something happens. It forms what? Double bond. Another bond is formed, which will make this alkene be reduced to an alkene. And that's not all. For this reaction to actually work, for the dehydrogenation to actually work, we need a metal catalyst. And this metal catalyst, I have examples with me. We have chromium 3 oxide, and we also can use aluminum oxide. Now, we also note that it needs high temperature, and I'm not talking about I mean a very high temperature like 400 degrees Celsius to 600 degrees Celsius for this metal catalyst to actually dehydrate this alkane to an alkene before we get our alkyne. Do we understand? So if you believe this video is not enough for you to like understand the preparation of alkyne, please check this video. I explained everything, drew the structures and the mechanism. I made it very clear for us. Okay, all right, thank you for watching. Make sure you like and subscribe, very important.